Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning. So now we will look at chapter 12, heat conduction and thermal expansion for subtopic 12.2, which is thermal expansion. Alright, so in this subtopic, the student should be able to 1. Define coefficient of linear, area and volume thermal expansion and solve problem related to thermal expansion of linear, area and volume. Include expansion of liquid in a container. Okay, so we have equation. Okay, we will look at the equation after this. Alright, so now we have one rod. The length of this rod is initially L0. And then we apply some heat to the rod and the rod will be expanded to L. Okay, the new length for this rod will be L. Okay. The question is why this rod become longer? Now we will look at real world example. We can see that the railroad tracks are made up with gaps. Okay, why the engineer built the tracks with gaps? It is because when they are heated by the sun, extreme heat or friction from the train, the railroad tracks will get longer. Okay, what will happen if there is no gap here? Now we have a cute sun with a box with area A0. Okay, and then the sun hitting the box and the box will be expanded to the new area which is A. Okay, the area become bigger. Expansion and contraction, when things heat up, the atoms speed up and move further apart from each other. Thus, the object expands and gets bigger. Okay, this is the thermal expansion of solid where we have a linear expansion, area expansion and volume expansion. So what I've been told you before this is only linear and area, but same goes with the volume. Volume also we expand when we apply some heat towards it. These are the examples of thermal expansion of solids in our daily life and some precautions that need to be taken to take care of the thermal expansion, such as gap, and then number 2 is loops are provided in metal pipelines carrying hot gases to allow for expansion and contraction and avoid damage, and then concrete blocks for pavements and road surfaces. And number 4, we can see that the iron rim is made slightly smaller than wheel. The rim is heated and slip in the wheel. Immediately cold water is sprinkled on it. Okay, so thermal expansion. Look at your lecture note. Thermal expansion is defined as the change in dimension of a body accompanying a change in temperature with linear area and volume expansion. All these three types of thermal expansion will occur in solid, but in liquid and gas, only volume expansion will occur. At the same temperature, the gas expands greater than liquid and solid. Linear expansion. So consider we have initial length L0 at temperature T0, and then we apply heat to a uniform temperature T so that the rod will acquire length L as shown in figure below. Thus, we have a change in length and we label it as delta L. Okay, delta L is the change in length where it is equals to L minus L naught. If delta T is not too large, where it is less than 100 degrees Celsius, then delta L is directly proportional to the change in temperature. So the equation for linear expansion is equals to delta L equals to alpha L dot delta T. So what is delta L? It is the change in length. Delta T is the change in temperature. And alpha is the coefficient of linear expansion. Okay, rearrange the equation from delta L equals to alpha L naught delta T. We can get that alpha is equals to delta L over L naught times 2 delta T, where the unit for alpha is per degree Celsius or per Kelvin. So what is meant by this alpha? It is a coefficient of linear expansion. Okay. It is defined as the change in length of a solid per unit length per unit rise change in temperature. If the length of the object at temperature T is L, okay, we can have this equation where L is equals to L naught times 2 alpha delta T plus 1. For many materials, every linear dimension changes according to both equations above. Thus, L could be the length of rod, side length of square plate, or the diameter radius of a hole, as long as the unit is meter. Okay, the dimension is 1 meter. So, honestly, I love to use the last equation where L equals to L naught times 2 alpha delta T plus 1. Okay, because from that equation, we have all the information L, L naught, alpha, and delta T. Okay, so other than this linear expansion, the equation for area and volume is actually the same, where for area, it will be equals to A equals to A naught beta delta T plus 1. And for V will be equals to V naught plus 1 plus gamma delta T.
Okay, so for linear expansion, we just use one equation where L is equals to L naught 1 plus alpha delta T. What is L? L is the length after B. L naught is the original length. 1 plus alpha is the coefficient of the linear expansion of that metal. And then we have delta T. Delta T is the change in temperature. And then for area, so we have area equals to A naught 1 plus beta delta T. For area, the difference is now E, and the unit will be in meter square, and this one is in meter, and another one is this beta. This beta we call it as coefficient of area expansion, and this coefficient of area expansion is equals to 2 alpha. And last one, the volume expansion. So the expansion in volume is equals to V naught, the original of volume, times 2 1 plus gamma delta T. What is gamma? Gamma is the coefficient of volume expansion, where gamma is equals to 3 alpha. So you just remember this one equation, L equals to L naught 1 plus alpha delta T, and from this one equation you can form another two equation, which is area and volume.